You know, in our digital world, true anonymity feels like a thing of the past. But for decades, one tool has been the absolute gold standard for online privacy: Tor, the onion router. Its whole promise is to shield your identity from prying eyes, and it's a crucial tool for a surprisingly wide range of people. But what if that shield isn't as strong as we all thought? What if a smart enough AI could be taught to see right through it?
So that's the big question we're diving into. Could a machine learning model, an AI, actually be trained to peel back the layers and spot Tor traffic, even when it's all encrypted and mixed in with everything else on the web? Well, the answer that researchers found is frankly staggering. Okay, so first things first. To really get what's at stake here, let's do a quick refresh on what Tor is. Its promise of anonymity isn't just about hiding your browsing history. For a lot of people, it's a matter of safety, and sometimes even freedom itself.
The entire design of Tor is built to make it nearly impossible for an outside observer to connect you, the user, with the websites you visit. It's a free, open-source project that has become the absolute backbone for private communication online.
And look, this isn't just for the hackers and cyber criminals you see in the movies. Not at all. Tor is a critical, day-to-day tool for journalists in dangerous places, for activists, for law enforcement conducting covert ops, and even for the military. Once you realize who really relies on this tech, you start to understand just how high the stakes are if its anonymity can be broken. So how does Tor actually work? Well, the name the onion router is the perfect analogy. It is all about layers. Let's peel them back and see what's supposed to make it so tough to trace. With your standard secure connection, that little padlock you see, HTTPS, your internet provider can still see the destination of your traffic, even if they can't read the content. But with Tor, it's a whole different ballgame. Your traffic gets wrapped in multiple layers of encryption and then bounced between a series of volunteer-run computers all around the world. So an observer, all they can see is that you're using Tor. Your final destination is buried deep, deep inside that digital onion.
Now, this layered defense, it seems pretty much impenetrable, right? But some researchers had a really interesting idea. What if they could train a kind of digital detective, an AI, to spot the super subtle clues that even Tor leaves behind? Let's take a look at how they set up their investigation.
The tool for the job is something called supervised machine learning. The easiest way to think about it is like this. You show a computer thousands of pictures. Some you've labeled cat and some you've labeled dog. You do that enough times, and pretty soon it learns to recognize the patterns of a cat or a dog all on its own. Well, these researchers did the exact same thing, but instead of cats and dogs, they used network traffic. And their process was incredibly systematic. First, they collected a ton of data. Then they extracted dozens of statistical features. You can think of these as tiny, tiny clues, like the exact timing between data packets or the average size of data chunks. They labeled all this data to teach the AI what to look for, and then, for the final test, they unleashed their trained model on new data to see if it could actually tell the difference. Now, to get the clean data they needed for training, they couldn't just tap into the public internet. It's way too messy. So instead, they built this completely controlled lab environment. They used virtual machines to generate pure, normal HTTPS traffic on one side, and on the other, traffic from popular sites like Google and Facebook that was being routed through Tor. This gave them a perfect, pristine, labeled dataset to train their AI detective. And the sheer volume of data here is really key. I mean, we're talking about almost a gigabyte of regular encrypted traffic and hundreds of megabytes from specific sites running through Tor. That scale is absolutely crucial, because the more examples you feed a machine learning model, the smarter and more accurate it gets.
All right, so the lab is set up, the detective is trained, and the evidence has been fed into the system. The huge question is, did it actually work? Could the AI really find a kind of digital fingerprint to distinguish Tor traffic from everything else? The answer was a resounding and, honestly, a pretty shocking yes.
Just look at that number, 99.64%. That is the accuracy the researchers' model achieved. Let that sink in for a second. Their AI could tell with near-perfect certainty whether a stream of encrypted data was coming from Tor or just a regular, secure website. The traffic that was supposed to be invisible was, to this AI, almost perfectly clear.
And this wasn't some one-off fluke with a single algorithm. Nope, they tested multiple types of machine learning models. You see Naive Bayes, C4.5, Random Forest here, and they all performed incredibly well, each one hitting accuracy rates over 99%. This just reinforces the fact that there is a real, detectable pattern in the data that these models can lock onto.
So the big question is, why did this work so well? Well, the researchers put it perfectly in their paper. The long-held assumption was that Tor traffic should look identical to regular encrypted traffic. Their work completely refutes that. They found that Tor and HTTPS have different flow characteristics, in other words, a unique digital fingerprint. All those extra steps Tor takes to bounce your traffic around the globe create these subtle patterns in timing and data flow that a human would never see, but an AI can spot with frightening ease.
An accuracy rate over 99% isn't just a cool number for a research paper. It has massive, and I mean massive, real-world consequences. This discovery is truly a double-edged sword for digital privacy.
On one hand, you can immediately see the appeal for law enforcement. A tool like this could potentially help identify and track criminals who use Tor to hide illegal activities. But, on the other hand, the exact same technology could be weaponized by authoritarian governments to hunt down dissidents, journalists, or really anyone just trying to access a free and open internet.
And this isn't some theoretical debate. As the researchers themselves point out, for people who are relying on Tor to communicate freely under these oppressive regimes, being identified as a Tor user could lead to imprisonment, or far worse. Breaking Tor's anonymity isn't just a technical challenge, it's a direct threat to human rights and to people's safety.
Which brings us to our final and kind of haunting question. This research shows that even the most sophisticated, most layered defense we've ever built can have a fingerprint that an AI can detect. So, as artificial intelligence gets more and more powerful, it forces us to ask, is this cat-and-mouse game between privacy tools and surveillance technology about to fundamentally change forever? And in this new era, is true online anonymity becoming a thing of the past?